Lesson 5.5 is titled Direct Variation. So make sure you have a title on your paper. Now you want to copy this definition down. A function that is in the form y equals k times x. This is very important, where k is not equal to 0. So k has to be a number, is a direct variation. So you really want to stress this, y equals kx. K cannot be 0. The constant of a variation for direct variation is the k part, and that's the coefficient of x. The variables y and x are said to vary directly with each other. So those are like the points on a graph that you'd plug in, the x and the y. But the k is your constant. Okay? So, is an equation a direct variation? So in A and B, if you notice, they give you two equations, A and B. And they're asking, is each equation a direct variation? If it is, find the constant of variation. So what you do is you solve the equation for y. So right here in letter A, if you look at this, they minus 5x and then they divided by 2. And they got y equals negative 5 over 2x. This equation has the form y equals k to the x, so the equation is a direct variation. It is a direct variation. If you look at the next one, I minus 5x and then I divide by 2. This is not in the form of y equals k times x because you have a whole nother number here, 9 over 2, which would be 4.5. But that 4.5 is not in the form y equals k to the x, so this is not a direct variation. So hopefully you can see the difference between the two. One just has a coefficient and a variable. The other one has a number and then a coefficient and a variable. So try these three problems, A, B, and C, and then we'll go over them. Okay, so here I'm going to divide by 7. So then I get y equals 2/7 x. Yes, this is a direct variation. Here I'm going to minus 4x. So then I get 3y equals negative 4x plus 8. And then I divide by 3. So y equals negative 4/3 x plus 8 over 3. No, this is not a direct variation. And then this one, I am going to add 7.5x to both sides. So then you get y equals 7.5x. So this is a yes, this is a direct variation. All right, writing an equation given a point. So it says write an equation of the direct variation that includes the point 4, negative 3. So here it tells us that it wants direct variation. So I'm going to start with this equation, y equals k to the x, which is what you wrote down at the beginning of this video. Now, here's my point. I have an x and a y. So I need to plug those two numbers in. So if you look here, they plugged in 3 for y and 4 for x. They got them right from here. Negative 3 for y and 4 for x. Sorry, negative 3, yes. Then you get negative 3 equals k over 4. You draw the line, you divide both sides by 4. So then you get k equals negative 3/4 x. Or k equals negative 3/4. And then you plug that in. So then you have y equals negative 3/4 x. You take out the 3 and the 4, and you just have your k. Notice this is just the k part. And then I'm going to leave my x and y, and I'm going to put those back in just as a normal x and y. So the direct variation is y equals negative 3/4 x. So write an equation of the direct variation that includes the point negative 3, negative 6. So try this. All right, so I'm going to start with y equals k times x. I'm going to plug in negative 6 for y and negative 3 for x. So then I would get negative 6 equals k times -3. I draw my line. I divide both sides by -3 because I want to isolate my variable. So these cancel out. -6 divided by -3 is 2. So k equals 2. So if I were to write my direct variation, it would be y equals 2x. I'm going to just take out the k and put in the 2 that I just found what it was. All right, real world problem. Your distance from lightning varies directly with the time it takes you to hear thunder. If you hear thunder 10 seconds after you see lightning, you're about 2 miles away from the lightning. Write an equation for the relationship between time and distance. So the distance varies directly with the time. So if x equals 10, y equals 2, because those two go together. They said that right in the thing, that the distance and the time are directly related. So if x is the number of seconds between seeing the lightning and hearing the thunder, and y is the distance, you would plug it into here. Y equals kx. I'm going to put 2 in for y and 10 for k, and then I solve this, and my equation is y equals 1/5 x. The equation y equals 1/5 x relates the time, x, in seconds it takes you to hear the thunder to the distance y in miles from the lightning. So, now, try this problem. A recipe for a dozen corn muffins calls for 1 cup of flour. The number of muffins varies directly with the amount of flour you use. Write a direct variation for the relationship between the number of cups of flour and the number of muffins. So try that problem. Okay, so you got to look at here. You have 12 muffins and 1 cup of flour. If you look back at this problem that we just did, they started with the thunder is 10 seconds and the lightning is 2 miles. So they put whatever came first was the x, and then whatever came second was the y. So if I go back to this, my muffins would be my x and my cup of flour would be my y. So then I have my y equals k times x. I'm going to plug in 1 cup of flour equals k times 12 muffins. I divide both sides by 12, so k equals 1/12. Whoops. So then you get y equals 1/12 x. So if I want 12, so I would just put in however many muffins I want. If I want 36 muffins, I would put in 36 here for x, and that would tell me that I need 3 cups of flour. Because 36 divided by 12 is 3. Okay, direct variations and tables. For each table, use the ratio y over x to tell whether y varies directly with x. If it does, write an equation for the direct variation. So you don't need to copy this down, I just want you to look at it, okay? And notice here, y and x, if you look, as I put the numbers in, -3, 1, 4, and 6, okay, this takes 4 to get to it, this is 3, and this is 2. The differences. And then here's what they got for their answers. And then if I looked at y divided by x, they all were the exact same. They all equaled the exact same. So this is a yes. The constant of variation is -0.75. The equation is y equals -0.75x. This is your k, your constant. Remember, your constant of variation, it would go right in for k. Now here, I have 2, 4, 6, and 9. So this goes up by 2, this goes up by 2, this goes up by 3, which really doesn't matter. But then what our outcome was, if I look here, all my numbers are different, except for these two are the same. These are all different, so this is a no. The ratio y to x is not the same for all pairs of data, so it is not a direct variation. So for the data in each table, tell whether y varies directly with x. If it does, write an equation for the direct variation. Okay, so here's my table. So then I'm going to make a table of y over x. So this would be negative 2 over 3.2. Take out your calculator. 2 divided by 3.2 is negative 0.625. And then I'm going to do 2.4 divided by 1 is 2.4. And then 1.6 divided by 4 equals 0.4. So these are not the same. So this is not a direct variation. This one, I'm going to do 6 over 4, y over x. 6 divided by 4 is 1.5. And then I'm going to do 12 divided by 8, which is 1.5. And then I'm going to do 15 divided by 10, which is 1.5. Yes, this is a direct variation, and my equation is y equals 1.5x. In a direct variation, the ratio y to x is the same for all the pairs of data. So the proportion y1 over x1 equals y2 over x2 is true for all the ordered pairs. So where neither x1 or x2 are 0, you can't have x1 or x2, the two numerators or denominators cannot be 0. You can rewrite a proportion as an equation for a direct variation also. So the force you must apply to lift an object is proportional to the object's weight. So this is what I was just talking about with the proportions. You would need to apply 0.625 pounds of force to a windlass to lift a 28-pound weight. So I don't know what a windlass is, but it tells me right here. Is a winch turned by a crank. It is used in a water well and to raise an anchor on a boat. Very interesting. So how much force would you need to lift 100 pounds? So force divided by weight, 0.625 divided by 28, which is about 0.0223. So if N is the force you need to lift 100 pounds, let W equal the weight and F equal the force. So if my force is F, then this would be my constant. I'm dividing those two numbers, okay? And that's my constant, so I'm going to put that in right here. And then I'm going to put W into, I'm going to put 100 into W. So then I times it by my constant, and I get, you would need about 2.2 pounds of force to lift 100 pounds. So try this equation, this little sample, and then we'll go over it. Suppose a second windlass requires 0.5 pounds of force to lift an object that weighs 32 pounds. So I would first find out what my constant is, my K. So then I would have 0.05 divided by 32. So this equals 0.0015625. And then how much force would you need to lift 160 pounds? So if this is my equation, y equals 0.00x, and then I'm going to put in 160 here. So I'm going to times that by 160. I would need 0.25 pounds of force. All right, that is it for your notes.